Okay, so question 42, give the major product of the following reactions. And we're going to go ahead and assume one equivalent of HBr for every one equivalent of this cyclohexene derivative. So because we're using only one equivalent of the HBr, basically the problem here is figuring out which of these two double bonds you're going to end up using as your nucleophile. Okay. So let's go through both of the possibilities and see what happens for each. Basically what this is going to come down to is trying to figure out um, which intermediate is going to be the most stable intermediate using either one of these double bonds, because both of them could potentially be used. What's going to be the deciding factor here is what or how stable the intermediate is that's formed for each possibility. Okay, so let's go through the first permutation of using this double bond right here. So we're going to use our nucleophile and the pi electrons right here, nucleophile, electrophile. Again, drawing our partial positive, partial negative. You don't have to draw these if you don't want to, but it's just easy to visualize this way. So again, we're making a bond, so we have to break a bond or else we'll violate the duet rule. So let's go ahead and break that hydrogen-bromine bond. Okay, and I'll go ahead and redraw this arrow as the blue possibility. Okay, so this is the first scenario. Redraw this cyclohexene derivative. Okay, and in this case, we can either put the positive charge here or we could put the positive charge here. Because remember again, just because we're using this pi bond as a nucleophile, it's saying nothing about where this resulting hydrogen ends up going at the end of the day. So you have to make that choice yourself, and the only way your audience knows, me specifically, the only way I know that you know which hydrogen or where the hydrogen goes to is by putting the carbon in the appropriate place. Okay, so let's just go through both possibilities in this scenario. So you can either have the hydrogen going up here, or you can have the hydrogen going on here. If you put the hydrogen on the carbon on the right, that means that this carbon on the left gets the positive charge. If you put the hydrogen on the left, that means the positive charge goes on the carbon on the right. Okay, so in this case, we have a very clear winner in terms of stability. You have secondary right here, and you have a primary right here. And both of these are just completely straight up secondary primary carbocations. There's no possibility for resonance for this first carbocation here versus here. Okay. So secondary versus primary. Now let's go through the other possibility. So let's say if we use this other pi bond, that's the second possibility. We can use that, push this over here, get the hydrogen, again, nucleophile electrophile relationship, and we're going to break this hydrogen-bromine bond. Please take away from this that I'm not saying that both of these events are happening simultaneously. So the blue arrow pushing event is totally separate from the yellow arrow pushing event. So this is just comparing and contrasting two different possibilities, and we're going to make a choice at the end of the day about what happens. Okay, so if we did it this way, we would end up getting two different possibilities. And I'll go ahead and copy paste both of these guys. Copy paste. Okay, and in this case, we can either put the hydrogen on this first carbon up top, or we can put the hydrogen on the carbon down below. So we can make that choice by comparing and contrasting, which carbon we would put it on. So let's go ahead and say for the first possibility, the hydrogen would go up here. Second possibility, hydrogen would go down below. So for the first possibility, we'd get this carbocation. Second possibility, we'd get the top carbocation. So let's go back to the blue scenario. For the blue scenario, we're having to choose secondary versus primary. Of the two, secondary is more stable, so secondary would win out if we did it this way. And for the yellow scenario, we have tertiary right here, tertiary versus secondary. So if we did it the yellow way, tertiary would win out over the secondary. Okay, so now of both of the possibilities, the yellow and the blue, we have the most stable carbocation that we would form for the yellow and the blue. So now to make that choice about whether we actually go through the yellow or whether we go through the blue pathway, we can compare and contrast what kind of carbocation we get. So for this first carbocation up above, secondary, second carbocation down below, tertiary. So of the two, tertiary is more stable. So of the two, tertiary is going to be the more stable carbocation. Okay, so because it's more stable, it's going to be easier to form. Because it's easier to form, it's going to have higher likelihood to form, and that'll mean that we have the bromine, the negatively charged bromine, acting as our nucleophile, and it'll end up attacking this carbocation intermediate. And what you'll get at the end of the day is this guy. Okay, you'll end up getting bromine substituted at this position right here. Okay, and this original double bond up above will be retained. Okay, and that's pretty much it for that question. All right, next question.